All right, so now we can do exactly the same thing we've been doing, but this time with definite integrals. And so what that means is we're not going to be plugging that x back in at the end, but it's still the same rule. So if you see a squared minus x squared, like this one, we're going to use x equals a sine theta. If we see plus, we'll use a tangent, and if it's x squared first, we'll use a secant theta. So we're obviously using the first one, and our a here would be 6. So x equals 6 sine theta, dx equals cosine theta, d theta. And then now we do the same thing we've done before. We're going to plug in our x. But we do it a little differently here because our x here is 0 and our x is 3. So we get 0 equals 6 sine theta, which we then would solve for by dividing by 6. Move this over. 0 equals sine theta, which means our theta, which is between negative pi over 2 and pi over 2, would become 0. And if we do x equals 3, then this would give us, I'm going to put it right there, 3 equals 6 sine theta, which would be divide by 6, so 1/2 equals sine theta. So that means our theta equals pi over 6. Okay, so now we take those values and replace everything. So our 0 is 0, our 3 is pi over 6, our x is 6 sine theta, and then on the bottom again we're going to get 36 minus 36 sine squared theta, and then our dx is 6 cosine theta d theta. And now we're done with x, don't have to go back to it. Just keep continuing on. So again, this is going to be the square root of 36, so it's 6 cosine theta. From 0 to pi over 6. So that 6 cancels. That cosine cancels. I should have probably just canceled the other one. Let's do that so it looks cleaner. 6, and we'll cancel that 6. That looks nicer. All right, so we end up with 6 sine theta d theta from 0 to pi over 6. Integral of sine is negative 6 cosine theta, pi over 6 to 0, and then we can just now plug it in. See, so it works a little bit nicer. You don't have to go back, substitute it for x again. Okay, so cosine of pi over 6 is negative 6 rad 3 over 2 plus 6 times 1. So this would become negative 3 rad 3 plus 6. Now, the best part is when you're dealing with a definite integral, our calculators will find the value for us, so we can check with our calculator. So it's 0 to 3, alpha y, and then x over second square root of 36 minus x squared dx. Hit enter. Okay, so we should get that for our answer. So now negative 3 second square root of 3 plus 6. Same answer. We're good. Now we move on to the next one. So we're going to first start by changing this to a 1/3. I should have noticed the 0 wouldn't work. We had a denominator of x cubed. So we're going to use 1/3 instead. So now everyone's got that changed. That's good. Now we go back up and we want to check which one of our expressions is going to work. So on ours, it's 9x squared. Let me zoom in a little more. It's 9x squared. So the x squared is first, so we're using this one, which means we choose secant. So we're going to do it the same way we did that one earlier problem. We're going to start by figuring out what do we want our x to equal. So we say that we know that 9x squared needs to be secant. So this would become secant squared theta minus 1. That's what we're looking for. See, we have a 9 in front here. It's not just a plain old a that we can use. So we've got to use a little trick. And then we do 3x equals secant theta. And so x is equal to 1/3 secant theta. And that's what we're going to use. X equals 1/3. So now we find our dx, which is 1/3 secant theta tangent theta d theta. We're going to move this one down a bit. There we go. Plug everything in. So this is 1/3 cubed, secant cubed, and then 1/3 secant theta tangent theta d theta. Now we need to deal with those a's and b's that start and finish. So we have 1/3 equals, and what I like to use, instead of using the 1/3 equals 1/3 secant, which is fine, we've already got this nice one here, so we can just plug it in there, and it tells us what our secant theta is going to give us. So that's 1 equals secant theta, and then we do the other one. So 3 square root of 2 over 3 equals secant theta. So square root of 2 equals secant theta. So now you can go back to your unit circle and figure out which is which. So we get theta equals 0, and we get theta equals pi over 4. So now everything is in terms of theta. We've got to make sure that we have everything in terms of theta. I made a little mistake right there. That's secant theta. Good. So since we're with respect to theta, we now go from 0 to pi over 4. What this means is we are done with the x. We don't have to go back to it at all. We just deal with what we have. Now we just have to simplify. So obviously that secant squared minus 1 with the square root around it is going to become tangent theta. And there's already a tangent theta here, so that would be tangent squared. And then we also have a 1/3 secant theta, so I'm just putting it all together. 1/3 cubed secant cubed theta d theta, 0 to pi over 4. So let's just double check everything. That's a tangent squared now. 1/3 secant theta d theta. Got everything plugged in. We're good. All right, now we just do a little canceling. So get rid of one of those, get rid of one of those, and we end up with 0 to pi over 4. Tangent squared theta over 1/9, which would become 9. So this is right here is 1/9, and then you're just going to flip it because it's a denominator. And we end up with this. So we can do whatever we did before. We can take everything and, we can either replace it with sine. Let's do sine cosine this time. So the last time we did secant. So we'll do sine squared theta over cosine squared theta times, and secant squared flipped would be cosine squared theta d theta, 0 to pi over 4, and then 9. And so this cancels. And we get 9, 0 to pi over 4, sine squared theta d theta, and then now we can replace that with 9, 0 to pi over 4, 1/2, so we'll put the half here, 1 minus cosine 2 theta d theta. And we're going to actually move that up to the top, right there, so we can continue on. All right, so this would become 9 over 2 theta minus 1/2 sine 2 theta from pi over 4 to 0. And then we plug that in, so it's 9/2, one giant bracket. And the first would be pi over 4 minus 1/2 sine. So pi over 4 plugged in would give us pi over 2. And then, oops, bracket doesn't end yet, parenthesis, minus, and then the next would be 0 minus 1/2 sine of 0, which is also 0. So that's just going to be 0. So we end up with pi over 4 minus 1/2, and then sine of pi over 2 is 1. 9/2 minus 0. I can get rid of that now, so we don't even need that. So this becomes 9 pi over 8 minus 9/4. And so that's what we should get when we do our calculator for this problem. So let's see what it gives us. So math 9, and then we're going to go from 1/3 to second square root of 2 divided by 3. Didn't scroll out of that. Common error, divided by 3. All right, looks good now. And then alpha y. Come on. And then, so that would be second square root 9 x squared minus 1. And then x to the power of 3 dx. Double check everything. 1/3. 9x. All right, looks good. Okay, so that's what we should get when we do 9 pi over 8. So 9 second pi divided by 8 minus 9/4. Cross our fingers. And there it is. So it checks perfectly. So there you have it. There's 2. And so they're all done the same way. The only difference now is instead of solving for x and plugging that back in for your cosine theta or sine theta or whatever, now what we're doing is just solving for theta and using those points. And so we never have to go back to the x ever again if it's a definite integral.